I'm going to quickly go over this article, published in the journal Hearing Research. This paper describes analysis of data from a study by Kurkela and colleagues in 2018. Their experiment was performed on 13 urethane anesthetized mice, and they recorded electrical activity from the auditory cortex while playing sequences of tones. Two versions of the oddball paradigm were played, with different interstimulus interval, or ISI, of either 375 or 600 milliseconds. The standards were 4 kHz tones, and the increasing and decreasing deviants were 4.5 and 3.5 kHz tones. The many standards or equal probability control was used, which included 16 different frequency tones presented at the same rate as deviants in the oddball paradigm. This control used an interstimulus interval of 375 milliseconds. The purpose of this study was to check whether the mice had a long latency mismatch response. This diagram illustrates part of the oddball sequence, with standards shown in green and deviants shown in red and blue. Usually single epochs are extracted from the data that each contain a response to one stimulus. This restricts the time window for analysis to the stimulus duration plus the interstimulus interval when another tone is played. In the double epoch method, the time window includes the responses to two stimuli, the deviant and standard, or two consecutive standards. In the single epoch method, mismatch responses are calculated by subtracting the standard response from the deviant response. In the double epoch method, consecutive standard responses are subtracted from deviant standard responses. The idea here is that the second standards approximately cancel each other out, allowing us to see deviant-induced long latency activity over a longer time window. Here's the data from the 600 milliseconds interstimulus interval oddball paradigm. Event-related potentials are shown on the top and mismatch responses are shown on the bottom. Onset of the second stimuli is marked with a vertical dashed line. The mismatch responses show a positive peak roughly between 100 and 200 milliseconds, then a later negative peak between 300 and 600 milliseconds. The onset responses of second stimuli approximately cancel each other out. Here's the data from the 375 milliseconds ISI oddball paradigm. The same pattern is observed here, although we can see a slight difference in the onset responses of second stimuli, which appears to induce opposite direction amplitude changes in the mismatch response waveforms. Despite this, there is clearly a long latency response extending through 200 to 600 milliseconds. When a similar analysis was performed on many standard stimuli, early differences between the onset responses was observed, producing opposite polarity amplitude changes in difference waveforms, but there was not the same long latency responses evoked by the oddball paradigms. So to conclude, the double epoch method was applied to electrophysiology data from anesthetized mice. Frequency oddball stimuli evoked long latency mismatch responses. This was absent from the many standards control waveforms. And together this adds more evidence that the rodent mismatch response occurs over a longer latency than previously considered. If you want to learn more, you're more than welcome to read this paper.